Recently, I published a video about the self-hosting community's trust problem. We talked about apps disappearing overnight, we talked about vibe-coded projects with no security practices, and we talked about what happens when you depend on a software maintained by a single person who has a bad day. A lot of you watched that video, and a lot of you shared it, and I thought, or hoped, that that was the end of it, and it turns out that wasn't the whole story. While solo developers quitting their own projects for whatever reason is one kind of trust problem, there's a different kind of trust problem that's been unfolding at the same time, and this one isn't about frustrated or even bad developers. This is one about sophisticated, well-resourced attackers who have figured out something important. The human element of open source software is a lot easier to crack than the code is. There were 3 pretty big attacks in 6 weeks, and none of them required finding a single code vulnerability. If you haven't seen the previous video yet, the link should be on the screen and in the video description. It provides good context for what we're covering today, but you don't need to have seen that video to follow along with this one. First, in March of this year, 2 high-profile open source projects were compromised in back-to-back supply chain attacks. And I want to give you enough context to understand today's story, but I'll keep this brief. But again, all of the details are in the previous video. The first incident was Trivy, and Trivy is an open source vulnerability scanner used by over 100,000 developers and embedded in thousands of automated build pipelines. A threat group called Team PCP exploited an incomplete credential cleanup from a previous security incident to poison the project's GitHub action tags. Any pipeline that ran Trivy during a roughly 3-hour window was unknowingly running attacker-controlled code that silently stole cloud credentials, SSH keys, and API tokens. And all of that was while the scanner appeared to function completely normally. The second incident was Axios, which is a JavaScript library with about 100 million weekly downloads and is present in roughly 80% of cloud and enterprise environments. And this one didn't involve any code vulnerability at all. North Korean threat actors spent weeks building a fake company, complete with a branded Slack workspace, fake LinkedIn profiles, and a fabricated Microsoft Teams call. They did all of this to socially engineer the lead maintainer into installing malware. Once they had access to his machine, they published 2 backdoor versions of Axios to the NPM registry. Luckily, if we can find any luck here, the malware was only live for about 3 hours before finally being caught. And the Axios maintainer had 2-factor authentication enabled, but it didn't help. Once a remote access Trojan controls your machine, software-based 2-factor authentication is just another app that the attacker can interact with. That's 2 attacks using 2 completely different methods. The first exploited an incomplete incident response, and the second exploited a person's trust in what looked like a legitimate business contact. And both of them reached millions of downstream systems. Just as a little side note here, I actually had something similar happen to my own system about 3 years ago, where I was duped into installing a malware under the guise of being a legit piece of software. And while I almost lost all of my social media accounts, I was lucky that I was the only person affected by the incident. So with all of that out of the way, here's the story that came across my feed earlier this week and made me realize that the previous video wasn't in fact the whole picture. On April 7th, the Open Source Security Foundation, or OpenSSF for short, which is a part of the Linux Foundation, issued a high-severity security advisory. Someone was impersonating a well-known Linux Foundation community leader on Slack, and they were using that identity to target developers working on Linux Foundation projects. If you're not familiar, let me quickly explain what the Linux Foundation actually is, because this matters for understanding why this is significant. The Linux Foundation is a nonprofit that stewards some of the most important open source infrastructure in the world. And when I say infrastructure, I mean the actual backbone that the internet runs on. 2 of the specific projects being targeted here are CNCF, that's the Cloud Native Computing Foundation, and To-Do Group. CNCF is the organization that maintains Kubernetes, Prometheus, and Envoy. If you run containers in your Homelab, if you use Proxmox, if you've ever spun up a self-hosted monitoring stack, you've touched software that CNCF stewards. The To-Do Group is focused on helping organizations manage open source programs. This is less directly relevant to Homelabbers, but it brings together the people who maintain the tools that the community depends on. The targets of this attack aren't random developers. They're the people who build and maintain the foundation underneath the software that your Homelab runs on. So here's how the attack worked. The attacker, posing as the Linux Foundation community leader, reached out via Slack attack direct message with a pitch. They were working on an exclusive private AI tool that could analyze open source projects and predict which code contributions would get merged before any reviewer even looked at them. And of course, they were only sharing this with just a few people for now. That lure is specifically engineered for the target audience. An open source developer receiving that message from a recognized community leader is going to be curious. It's plausible. It's interesting. It exploits exactly the kind of professional trust that makes open source communities function. The message included a link hosted on Google's sites, and this is the detail I want you to really pay attention to. The URL was a legitimate sites.google.com domain. It looked real because it's real infrastructure that's being misused. The page mimicked a Google Workspace sign-in flow and asked users to enter the credentials and verification code. Then it asked them to install what's called a Google certificate. The problem is that it was not, in fact, a Google certificate. It was a malicious root certificate that, once installed, allowed the attacker to silently intercept all encrypted traffic between that targeted device and every website the person using the device visits. On macOS, a script then automatically downloaded and executed a binary that gives the attacker potentially full control over the machine. And on Windows, the malware installed via a web browser trust dialog. Google has since taken down the spoofed pages, which is good, and the OpenSSF confirmed that this follows a pattern of similar attacks against Linux Foundation projects over the past several months. At this point, no one knows who is behind this specific campaign or whether it's connected to the same North Korean group behind the Axios attack. What is known is that the technique, impersonating trusted community figures to deliver malware through legitimate-looking infrastructure, is the same playbook. So if we step back and look at these three incidents together, a pattern becomes very clear. The Trivy attack didn't exploit a bug in the scanner. It exploited trust in GitHub action tags. The assumption that if a version tag says version 0.28.0, you're running the code that's always been at 0.28.0, but you're not. The problem is that tags can be silently repointed to different code at any time, and I really feel like this is something that should be addressed to help fix these kinds of attacks. And the Axios attack didn't exploit a vulnerability in the library. It exploited the trust a maintainer placed in what looked like a legitimate professional contact on platforms that he uses every day: Slack, LinkedIn, Microsoft Teams, the normal tools that a lot of people use at work. The Linux Foundation attack didn't exploit a flaw in Google's infrastructure either. It exploited trust in a recognized authority figure and trust in a URL that genuinely belonged to Google. Google's own spokesperson was pretty explicit about this. It was platform abuse, not a security vulnerability in Google's systems. The phishing page was hosted on Google sites the same way that anyone can host a page there. None of these required finding a zero-day vulnerability. None of them required sophisticated malware development up front, and all three required something much simpler: understanding how trust works in open source communities and then exploiting it. The OpenSSF CTO put it clearly in the security advisory. This campaign highlights a growing trend. Attackers are targeting developer workflows and trust relationships, not just software vulnerabilities. When reaching one person means reaching every project that they maintain and every system downstream that depends on those projects, the math just makes sense. Why spend months hunting for a code vulnerability when you can spend 3 weeks building a convincing Slack persona? Now, at this point, I want to bring you back to the practical level, because I know some of you are thinking, this is all enterprise CI/CD stuff. What does this have to do with my Homelab? More than you might think, unfortunately. If any of you run any kind of automated pipeline like GitHub Actions, self-hosted runners, anything that uses Trivy or GitHub Action tags, the lesson from the Trivy attack is straightforward. Pin SHA hashes, not version tags. A SHA hash is immutable. Nobody can change what commit it points to. A version tag is just a label, and labels can be moved. The previous video covered pinned Docker image tags for the same reason. This is the same principle applied to GitHub Actions. If you have any JavaScript projects or applications in your Homelab that use Axios, check your dependency versions. The compromised versions were 1.14.1 and 0.30.4. If you ran either of those in the window between March 31st and when npm pulled them, treat any credentials that the environment had access to as compromised and rotate them. More broadly, and this applies to everyone, the Axios attack should change how you think about unsolicited collaboration requests even on platforms you trust, whether it's Slack, LinkedIn, Discord, or even email. The attackers targeting the Axios maintainers spent weeks building credibility before they made their move. They created a fake company with real-looking LinkedIn profiles. They set up a branded Slack workspace with multiple channels that were sharing industry news. They played the long game and were very, very patient. So here are some specific red flags to watch for, regardless of the platform. Anyone asking you to install a root certificate, full stop. Legitimate services do not ask you to manually install root certificates. Google's own spokesperson said it explicitly after this incident. Legitimate Google Workspace authentication will never require you to install a certificate or download a binary from a link. If anyone asks you to do this, the answer is no. Unsolicited requests that come with urgency or exclusivity. We're only sharing this with a few people. You need to do this before the call ends. These are social engineering pressure tactics. Real collaborators don't need you to bypass your judgment. So now let's talk about verification out of band. If someone claiming to be a known community figure reaches out to you on Slack with an unusual request, verify their identity through a separate channel before acting. Send them an email, check their official presence elsewhere, and just a few seconds of doing that is definitely worth the risk that you can avoid. This is actually something that I do on a regular basis as a content creator when a brand reaches out to me. It's too easy to spoof an identity, so I'll reach out to the brand via social media or their official email addresses found on their official online assets. And the broader lesson, the software your Homelab runs is only as secure as the people who maintain it. I don't mean you, I mean the people building the upstream code that your Homelab relies on, and those people are being very actively targeted right now. The self-hosting community has always understood that trust in open source matters. What's new is the evolving level of sophistication being used to attack that trust. I still believe that open source software is worth trusting. It's been the foundation of everything from the internet itself to your Proxmox server to the container images you pulled this morning. The fact that it's being attacked this aggressively is actually a reflection of how valuable it is. But trust has to be informed. The checklist from the last video still applies. And add to that, think about where the software in your stack comes from. Think about how it gets updated and whether the people maintaining it have the kind of support and security practices that protect them from what we just covered. The attackers targeting open source right now are patient, well-resourced, and specifically targeting trust. The best defense against that is a community that understands what's happening and talks about it openly. As always, all of the resources are linked in the video description, so drop your thoughts in the comments. I'm especially curious whether any of this changes how you think about how your Homelab is set up. But guys, I think with all of that said, I'm going to wrap this up. I do want to thank you guys for spending a few minutes of your day with me here today, and I'll talk to you in the next video.